Okay, we've already figured out the dimensions of this box for maximum volume, so we're just going to answer this verbally. For step 7, for step 8, we had h is 3 and x is 6 from step 7. So from step 7, x is 6. From step 8, h is 3. So verbally, given, so that's our step 9. We just want to answer it in a way that makes sense in a sentence. Given 108 square feet of cardboard, a box of dimensions 6 by 6, so the base of the cardboard, by 3, so 3 being the height, will produce a maximum volume of 108 cubic feet. Notice how thorough it was. Notice my dimensions were all included there. Remember, x was the base, and h, which is 6, and the height would be 3 feet. And so you just want to answer it verbally so that you're very clear about what dimensions produce the maximum volume. And again, if you read this question to somebody, especially somebody that was, in construction or something, it would make sense to them. Okay, you were given this amount of material, this is the dimensions of your box, and that will give you the maximum volume of 108 cubic feet. Again, if we go back to the picture, this makes more sense as we look at our answer and compare it to the original figure. Okay, so 6 by 6 by 3 will give you a box of maximum volume, which ends up being 108 cubic feet. Now, I just now noticed this is the same number as the square footage that you were given. That is definitely a coincidence, so do not think that that always happens. It just happens to be the case this time. Going on to example 2, you want to answer this one verbally. The dimensions of these two shapes that give you a minimum amount of area given 10 inches of material. We figured out x to be 1.883 and y to be 1.087. So for step 9, when we answer verbally, let's read this together. When the triangle of side length x equals 1.883, so notice I said that triangle, when the triangle of side length x equals 1.883 inches and square of side length y equals 1.087 inches are created, a minimum total area of, going back to up here, 2.718, which is our smallest area, and the units would be square inches, is achieved. So that's it. This one was easy to answer since we knew the dimension, the side length of the triangle x, 1.83, and the side length of the square y equals 1.087. Going to the last example, we kind of skipped over step 8 because we didn't need any additional information. We determined that if we charged $11.60 for rent, we would make a maximum profit of $27,040 per month. So that's what we're going to say in our answer for step 9. When the owner of the apartment complex asks for $1,160 in rent, he or she achieves a maximum profit at $27,040 per month. So that's it. We are done. Once you answer verbally, you are done with optimization. And again, I think the optimization is a little bit easier than related rates just because there's less steps and because, usually, since you have a constraint equation and your optimization equation, you can take the constraint and just get the optimization in terms of two variables and then take the derivative from there. And furthermore, it's an optimization equation when it involves this superlative such as greatest or least amount, maximum or minimum. And I also think it's easier just because I think the steps are a little bit more, how should I say? I think it's a little bit more predictable, whereas with related rates, sometimes it's a little bit more open-ended and takes a little bit more critical thinking. But either way, both related rates and optimization are a wonderful way of using calculus and applying it to the real world. If you have any other questions about optimization, let me know.